Okay, this video is going to focus on what we call a product of secant tangent, but I want to start by looking at these powers here for tangent. I'm going to want them to be odd here, so let's look at how this works when I have odd powers of tangent. So I'm going to switch this order here. I'm going to just say I got a tangent cube and I got a simple secant x dx. So notice my power for tangent is in fact odd. So here's our procedure. This is what we're going to do first. We're going to factor out a secant tangent from our function here that we want to integrate. So we're going to factor out secant tangent. Here's how this looks. I get secant tangent times tangent squared. This is what they mean by factor out that secant tangent. And let's put that in red, I guess. Now, the next part of the procedure, the recipe, is going to be the following. You're going to use the Pythagorean identity. So we're going to use the fact that tangent squared x is equal to secant squared x minus 1. So there's a tangent squared x term here. I replace it now with secant squared x minus 1. So here's what we now have. We have that secant tangent factor times secant squared x minus 1, replacing my tangent squared. Now, as you guys might be able to start to guess, the reason we factored out a secant tangent is because we're going to let u be simply secant. Notice, derivative of secant is secant tangent. And there's a dx here. Okay, so this is what we're going to use. We're going to use these 3 to 4 facts when we integrate an odd power of tangent here if you have a secant function there as well. Okay, so this is kind of what the focus is on this particular procedure for integrating these type of functions. So now let's do the u sub. Now remember where we're at. We're right here. We have secant tangent. This is now going to be u squared minus 1, and I'm supposed to integrate with respect to dx. Now, the whole reason we let u be secant is so we can get our nice du over here. Here's the du. It is secant tangent dx. So here's my factor of secant tangent. Here's my dx. I get to replace these terms with simply du. So I have the integral of u squared minus 1 du. So together, these are my du. And now I can integrate from calculus 1. We know that's 1/3 u cubed minus u plus that c. We just have to go back and remember what is u. And remember what we said u would be. U is actually secant. So my final answer is going to look like this. 1/3 secant cube minus secant plus c. Here you go. Here it is. So let's do this again here. Let's practice this procedure. What if we have tangent to the 5th power? Now change this to a secant squared. Notice the point of this idea here. You do have an odd power. It's the 5th power of tangent now. So the first procedure is to factor out a secant tangent, or the first part of this. So secant tangent times, remember, we're factoring out a secant tangent from this product. That'll give you another secant, and that'll give you tangent to the fourth power. So here's what we factored out. I'm going to set that aside because that's going to be part of my du. And now remember what else we have to do. Since u is secant, I have here tangent to the fourth power. So in order to use my Pythagorean identity, I have to write tangent to the fourth as tangent squared because power 2 raised to power 2 is power 4. What happens now for that tangent squared here, we're going to now replace it with what we're supposed to replace it with, and that'll be secant squared minus 1. Okay, so let's look at what we have here. We're going to let u be secant. So now wherever there's a u, let's find the u. Here's secant. That's now going to be u. Over here, secant squared. That's going to be now u squared. So let's put everything together now. I have my integral secant tangent u times u squared minus 1 squared dx. So at this point again, since u is secant, du now becomes secant tangent dx. Here's my du. Secant tangent dx. So this is going to be my du now. Okay, so I have u squared minus 1 squared du. Now over here, I'm going to use some algebra. Meaning, u times u squared minus 1 squared is, well, a couple of copies of u squared minus 1. This becomes u times u to the fourth minus 2u squared plus 1, or we can say u to the fifth minus 2u cubed plus u. So we're going to integrate now u to the fifth minus 2u cubed plus u, and that'll be with my du. Okay, 1/6 u to the 6 minus 2u to the fourth over 4 plus 1/2 u squared plus this c. So I'll now get 1/6 u to the 6 minus 1/2 u to the fourth plus 1/2 u squared plus c. Now remember what u is. Secant. So my final answer is going to be the following. Let's put a secant there. 1/6 secant to the 6th power minus 1/2 secant to the 4th power plus 1/2 secant squared plus that constant c. Final answer. And this is how we go about integrating odd powers of tangent. So let's kind of look at another example here. Tangent to the cube power, secant to the cube power, dx. Once again, my power is odd. Let's factor out a power of, or a factor of secant tangent. So this will be secant tangent times tangent squared, secant squared. Okay, so remember, in this process, u is secant, which means du is secant tangent. Let's write this a little clearer. So that's why we save this factor of secant tangent. So we're not going to deal with that. That's going to be our du. Don't forget there's a dx here. Okay. Now, since u is secant, that also means this becomes u squared. We just have to handle our tangent squared being secant squared minus 1. So all together now, we have the, let's get this, integral secant tangent times u squared minus 1, because I got secant squared minus 1, that's u squared minus 1, and don't forget times the u squared out here. This is the u squared. So I already used this identity, and this will now be dx. So let's remember that our secant, if I change that color, let's see, secant tangent dx is what we replace with du. So this is the integral of u squared minus 1 u squared du, which is u to the 4th minus u squared du. And we end up here with 1/5 u to the 5th minus 1/3 u cubed plus that c. So remember, u is secant. So replace a secant wherever there's a u now. Final answer. 1/5 secant to the 5th x minus 1/3 secant cubed x plus that constant c. There you go. Now, I'm just going to toss in a couple of remarks here. Let's note, what if you had a u sub version of all of this? For example, I can have tangent of 2x secant squared 2x, or let's do secant cubed, 2x dx. Now, I didn't remark, but you can actually use the procedure here. If we notice, first of all, the power for tangent is odd. And yes, that's going to be a u sub. There is a procedure for odd powers of secant that we discussed in the last video. It could be done with that as well, but we're going to focus on these odd powers for tangent. Or I'm sorry, we had even powers of secant. So we're good. We're going to focus on the odd power here. So this will be u sub, and let's see how we go about that. I want to let u be 2x, which means our du is 2 dx, or our dx will be du over 2. So this integral now is tangent of u secant cubed of u du over 2. Let's pull out the 1/2. 1/2 integral tangent u secant cubed u du. So what we'd have to do is actually come up with a formula here for this. And it's very similar to what you already have. So I'm used to doing things in terms of x, so it's up to you. This will be our u sub version of the formula. So let's go back, and I'm going to say here's a big note, or here's the question. what is the integral of tangent x secant cubed x dx? Again, we have a power 1, which means this is an odd power of tangent. So if we follow our procedure and say we're going to factor out a secant tangent, we're left simply with secant squared. U again is secant, and du will be secant tangent dx. So my secant tangent, that's going to be part of my du. And if u is secant, this integral now becomes, I'll put secant tangent u squared dx. Notice, secant tangent dx is my du. So we have the integral of u squared du, which is 1/3 u to the third plus c. Now don't forget, u is secant. So the final answer here is going to be 1/3 secant cubed x plus c. Now that's what we're going to use here, I should say. This is the integral we asked. What is this? So we can generate the u subversion of this. Well, we already know what it is. It is 1/3 secant cubed x plus c. So in other words, here's what happens. I'm going to replace this integral right here in gray with what it actually is, 1/3 secant cubed plus c, but I'm going to change my x to a u. So don't forget there's a 1/2 now. So let's go back here and say we got 1/2 now times this integral, or I should say this function, 1/3 secant cubed. Now it's going to be u, because we're going to change the variable from x to u. We have the u subversion. This is the arithmetic we're doing. And so we get a nice 1/6 secant cubed u. You can say 1/2 c, but that's a constant again. This is simply 1/6 secant cubed u plus a constant. Now we have to remember, what is the original u? Well, the original u here is going to be all the way back over here from the problem. Here's my original u. It's actually 2x. So my final answer now. 1/6 secant cubed 2x plus my c. So there's a u subversion here with these odd powers of tangent. I'm sorry. Yeah, these are some odd powers of tangent, I guess. Are they odd? Are we doing the even? Yeah, these are odd. All right, well, let's continue with this odd powers of tangent here. And I want to do something here a little different. Notice again, there's no secant. My power here is still odd, but there is no secant. Let's note, we have the first odd power of tangent, which is the natural log absolute value of secant plus c. So we did this in the past. Now let's see about continuing these odd powers here and what this does for us. We have a procedure that said, back to the original problem, that was to say, factor out a, from this original integrand, a factor of secant tangent. But if there's no secant, we're going to have to just factor out tangent. So we're going to factor out a single tangent. What that gives us is tangent times tangent squared. So that's our first step. Here is that factoring out of the tangent. And let's go back here. We forgot to write tangent x. Okay. Factor out that tangent. Now they also said in the last procedure, you're going to replace tangent squared now with our secant squared minus 1, the Pythagorean identity. And if you do here, we're going to have tangent times secant squared minus 1. Now, let's be careful here. Last time we said, in this case, let you be, we're going to have a problem here if we look at this. Last time we wanted our u to be, let's see, looks like our u last time for these odd powers was secant. And so if I let u be secant, yes, this becomes u squared minus 1, but the derivative of secant is secant tangent. So let me write this. If u is secant, I get u squared minus 1, but the derivative of u is secant tangent. There's only a tangent. There's no secant. So that's a problem. So I can't let u be secant in this problem here if there's no secant to begin with here. There's no secant multiplied there. So this is how this is a little different. So what I'm going to suggest you to do is the following here. Okay, this is how we handle this problem. I'm going to distribute now, which is what I didn't do in the past. I'm going to distribute my tangent, and I get tangent secant squared minus tangent. So this integral now is an integral now of tangent secant squared minus tangent x, and there's a dx here. I want to point out to you something very interesting here with this odd power of tangent. Properties of integration says I have a tangent times a secant squared dx minus this integral of tangent dx. So I have two integrals here. I make the claim now I can do both. You see, the second integral, we already know, if we integrate tangent, we know this is going to be natural log absolute value of secant. And yes, it'll be plus a constant, but okay. We already have this integral. The question is, what about this integral? And if you notice this now, we're in that format where we can actually integrate. I think we might have even started off with this one already. Is that our first question? Tangent secant squared. Let's go back. No. Looks like we don't have a tangent secant squared. That's okay, because what do we notice about this particular problem here? What's the power? The power for this tangent is actually odd. So when the power for tangent is odd, yes, by u sub, yes, we'll let u be, or let's go back. We can either use u being secant. We can follow our procedure here. But you know what I noticed as well? Let me change colors here. You have a even power for secant. Now let's stop and think about the last video. So not only do I have an odd power of tangent and I have an even power of secant, this video focused on, I'll put it in purple here, how to integrate tangent with a secant coming after it, meaning factor out a secant tangent, and you can do that here. But here now, I want to point out, we did have a past video where you had even powers of secant. And I think at this point, I might say, why don't we try doing that? Let's let u be here. In this case, when you have an even power of secant, u becomes tangent. Let's see the past video, so that's what we're looking at here. An even power of secant. If u was tangent here, the derivative of u, du, is secant squared x dx. So now this integral really becomes here u for this tangent, and then secant squared dx is really my du. So I get 1/2 u squared, which is really 1/2 tangent squared x. So altogether, here's my first integral. It is 1/2 tangent squared x, and then here is my second integral minus the natural log absolute value of secant plus c. So as we go along with our procedures here, it pays to be a little bit awake in terms of what we notice. We have an even power secant, so we now are able to integrate that rather nicely and easily. Okay? If you try to go about the other approach, because that's secant squared, you may have a problem. If you went with the odd power, you might want to check that out. Okay, so just want to point out to you a couple of things that you can see now that you have some experience integrating here with these trig integrals. Let's look at one more and see how this works for us now. We're going to look at the next power, right? Because this one was simply integrating tangent cubed, which was odd. Let's integrate this power, tangent to the fifth power. Again, this one is odd. We got another odd power. So as we generate these powers, I'm going to remark, notice that tangent squared, and there is no secant to factor out. Right? There's no secant. So I'm going to factor out maybe a tangent, and I get tangent times tangent to the fourth power of x. I can also factor out, let's do another remark here, tangent squared, and that gives me tangent cubed. And so what I think I'm going to try here to show some sort of pattern now for you is I'm going to go with this second version. And what I'll do now is I'm going to replace here, I'm going to find red, my tangent squared with the Pythagorean identity secant squared minus 1. So what we're going to end up here with is secant squared x minus 1 times a tangent cubed x. Now let's do what we did before. Let's actually just FOIL here. So I'll get secant squared x times tangent cubed x minus tangent to the third power. This is what we are really having to integrate. Now, by properties of integrals, I have integral of a difference is difference of integrals. Let's subtract the integral of tangent cubed dx. Now here's my point. The reason I approached it this way is because now again we have these kind of interesting scenario here. Let's put this in purple. Here is an even power of secant. Here in blue is an odd power of tangent. we might have done this one. Maybe this one was the one we started off with, or maybe this one here is the second. So let's find out. That's tangent to the third power and secant squared. So tangent to the third power and secant squared. Not there. Not there. Not there. So it looks like we're going to have to do this ourselves again. But I want to point out we may have some choices here. Okay? I want to also remark, guess what? This integral here we already did. Let's see the last example. Let's put that over here. Let's do this here. By the last example. Last example of tangent cube we have is what you see here. 1/2 tangent squared minus the natural log of secant. So this is 1/2 tangent squared minus the natural log absolute value of secant. Yes, plus a constant. That's for this integral here. So then the question really is, and I'll put it down here again, what about that first integral? Secant squared x times tangent cubed x dx. And again, I happen to notice I have here the odd power. So since the title of this, or since the approach here is to actually working with these odd powers of tangents, let's go with that. I'm going to say let's factor out a secant tangent. So if you do, this becomes secant tangent times secant tangent squared. Okay, so here's my factor of secant tangent that I just factored out. Let's double check. It is secant squared tangent squared now, right? This is the integrand, or what we're trying to integrate, this function. This is the process. Now, again, because we factored out secant tangent, that means u is going to be secant, and du is secant tangent dx. We're going to replace our tangent squared now with secant squared minus 1. And again, because my u here is secant, wherever there's a secant, I replace it with a u. So here's a secant, here's a secant squared. We're going to replace them with a u. Secant tangent u times u squared minus 1. And there is a dx, and we are integrating. So notice here again, du would be secant tangent dx. Here's my du. So I'm now going to integrate u squared minus 1 du, which is the integral of u cubed minus u du. 1/4 u to the 4th minus 1/2 u squared plus c, where u is going to be secant. So my final answer here is going to be 1/4 secant. Let's go up here. 1/4 secant to the 4th minus 1/2 secant squared. And that's just the first integral. That's just this one. That's just the one we just did here. Let's not forget the rest of this, which is 1/2 tangent squared plus 1/2 tangent squared minus natural log absolute value of secant plus c. So that's your final answer here for these problems involving tangent. Okay. Well, let's consider some other kind of problems that you guys can see. What about if they're even powers of tangent? So if I have tangent squared dx, notice here, my 2 here is even. Well, as you might have guessed, we're going to use our Pythagorean identity. I'm going to replace tangent squared with secant squared minus 1. So this becomes the integral of secant squared x minus 1 dx. And integral of a difference is difference of integrals. So this portion here now simply becomes x plus c, and we know the integral of secant is actually just simply tangent. So final answer is going to be tangent minus x plus that c. This is tangent squared. Now let's go to another power here. That's even. Let's generate powers here of tangent. Here's a fourth power. This one is an even power. So as you guess, we may want to write our tangent to the fourth as maybe tangent squared, tangent squared. And we're going to replace, using Pythagorean identity, we're going to replace this with a secant squared x minus 1. So altogether here, you're going to end up with your tangent squared times our secant squared minus 1. Now, just multiply like we did before with the last set of examples. You'll get tangent squared x, secant squared x, minus tangent squared. Now this is what we really have to integrate. So the integral of a difference is difference of integrals. So I have a tangent squared x, secant squared x, dx minus the integral of tangent squared x dx. So I want to remind everybody that we already integrated tangent squared here. The last example, looks like tangent squared here is tangent x minus x plus that c. That's right up here. Now, since we notice here as well that, let's change this color, my power for secant is even. By our u sub, we're again going to let u be tangent, which means derivative of tangent is actually secant squared, or we can say simply that dx becomes du over secant squared. Okay, so let's kind of do this again. I'm going to change the color. Maybe you can see it a little better. And let's try that. U is tangent. Derivative of tangent is secant squared. So this is what we're going to integrate here. So that becomes u squared. Yes, that's secant squared dx. Remember, secant squared dx is actually du. This portion is du. So I'm integrating u squared du, which gives me 1/3 u to the third plus c, where u is tangent. So here's going to be my final answer. Let's go back here. U is tangent. I replace that here. So I'm going to write everything down. 1/3 tangent cubed x. Don't forget, minus this integral. Minus tangent x plus c. You see, because that's already negative, we distribute that negative sign to this particular difference here. Now it's kind of looking a little, let's change that color. Distribute that negative sign here. That now makes this minus and this plus. Okay? So this is going to be our final answer here for this even power of tangent. And so we can do this over and over again. We can generate here tangent to the 6th power. And we can see the pattern of how this is going to go about. Again, we're going to factor out a tangent squared. So let's first start again with all of this and remark that even power tangent to the 4th power times tangent squared. And here's the pattern again we're going to use. Replace this with our secant squared x minus 1. So I end up with tangent to the 4th x times secant squared x minus 1. Distribute again. So I get tangent to the 4th power of x, secant squared x minus tangent to the 4th power. Now this is really what I have to integrate. So the integral of a difference is difference of integrals. Integrate tangent to the 4th power of x, secant squared x dx minus the integral of tangent to the 4th power dx. I'm going to say to you here, this integral see last example. We already did that one. What we're going to focus on here is this problem. And notice again, let's get rid of that. You have an even power of secant. So we had a procedure for how to perform U sub when you had an even power of secant again. Again, U is tangent. You're going to go back to that procedure. Derivative of tangent is r secant squared dx. So that means I have u to the 4th du, because secant squared dx is really du. Now that becomes, when you integrate by power rule, this equals 1/5 u to the 5th plus c. Don't forget what u is. U is tangent. So let's write our final answer. 1/5 tangent to the 5th power of x minus the last example answer here. See this? See last example? This is what we need to write down, but it has to have the opposite signs because there's a minus here. Sorry, there's a minus there. Okay? So let's write the opposite signs down. Minus 1/3 tangent cubed. Okay. Plus tangent. Change the sign. So it's minus, it's now plus. Now plus, that's minus x plus my constant c. And this is how we go about integrating higher or generating even powers of tangent. And of course, you do have all the u sub versions if you so chose to go about it. You know, we can kind of do something like that if you wanted. I'll say, by the way, let's look at this example here. If it came to it, we had to integrate tangent to the 6th power pi x dx. You notice that pi x, of course, that means u sub. U is pi x, and my du is pi dx. Or we can say dx is du over pi. So my u sub gives me tangent to the 6th power of now u du over the constant pi. And we're going to pull out this constant pi, and we end up with 1/6 integral tangent to the 6th power of u du. This is by our u sub approach. Now, we know what this integral is. It is right up here. I know the variable here is x, we just change it to u. So let's do that. 1/5 tangent to the 5th power. So let's write everything down here. This is 1/6 times 1/5 tangent to the 5th power of u minus 1/3 tangent to the 3rd power of u plus tangent of u minus u plus c. So when you distribute now to all these terms, final answer, we'll get 1/30 tangent to the 5th power of u minus 1/18 tangent to the 3rd power of u plus 1/6 tangent of u minus 1/6 u plus a constant c. Remember what u is here. Pi x. Let's write down the final answer. Pi x here. There's going to be a pi x here. Pi x here. Pi x here. Pi x here. Don't forget this is a 6. 1/30 tangent to the 5th power of pi x minus 1/18 tangent to the 3rd power pi x plus 1/6 tangent pi x minus pi x over 6 plus some constant c. Here you go. This is how we handle the u subversion and a even power of tangent only.